Here the first figure is given and we have to find out the reliability of the equivalent reliability of the system. So for each system you have to consider zero 0.8 as the given reliability. So first of all, the system here connected is in series, so R and R, these two, both these R are connected in series, so the reliability is the R square, which is again connected with in parallel to this branch R, so it is 1 minus R and 1 minus R square. So this is the combination of this branch 1 minus R and 1 minus R in one combination, and this there are two such combinations available. So it is 1 minus R, 1 minus R square in top, and 1 minus R and 1 minus R square in bottom. So it is equally can be written like 1 minus R into 1 minus R whole square, like this. Now again R and R connected in parallel, so it can be written as the equivalent reliability of the system for this combination is 1 minus 1 minus R square. So the total reliability of the system now can be written as 1 minus 1 minus R square into 1 minus, in the bracket of 1 minus R into 1 minus R square whole square, bracket complete. So now if we are putting the value R is equals to 0.8 in this system, so we are calculating likewise and the answer is 0.9550. so answer is D in this case. Now for the second to fourth question, they are correlated with one each other. So first of all, voltage magnitude and current magnitude that are given in the form of equation. So we have to find out the value of RMS voltage and RMS current. So first of all, DC component of voltage is given. Voltage of fundamental is 100 root 2 divided by root 2 can be given. So maximum value divided by root 2 is the RMS value, so 100 volt RMS, and the third harmonic component maximum or peak value is 50 root 2 divided by root 2 can give us 50. So the RMS value of the voltage is in the bracket under root of 20 square plus 100 square plus 50 square, so it is equals to 113.57, so 113.58 volts. And the current magnitude similarly can be calculated with DC fundamental and third harmonic component, so it will be like 2 square plus 5 square plus 10 square equals to 11.3578 amperes. So answer is B in this case. Now displacement factor can be calculated for the fundamental frequency component only. So in the voltage wave, if you find that there is no phase angle given, so phase angle is 0 for voltage, and for current it is minus 30. Minus shows the lagging value of the current. So there are two options which are having lagging values. Now we can calculate. So cos theta voltage, so theta of the voltage minus theta of the current. So displacement can be calculated from the fundamental. So 0 minus minus 30, that is 30 degree positive. So cos 30 is equals to 0.866, and minus shows the lagging side, so it is lagging. So answer is B, 0.866 lagging. Now we have to find out the total harmonic distortion for voltage and current. So total harmonic distortion of from the voltage is the under root of V3 square, that is third harmonic component. So third harmonic's magnitude is 50 in RMS, so 50 square divided by 100 in the RMS value of the fundamental, so 50 square divided by 100, so it is 50 by 100, that is 0.5. So 50% of total harmonic distortion in the voltage waveform, and for current it is 10 square under root of 10 square divided by 5, so it is 2 or say 200%. So answer is C, 50% of voltage harmonic in total harmonic distortion, and for current that is 200%. Now failure rate of a distribution feeder is given as 0.75 faults per 10 years. So here you can calculate like this. Faults per hour can be calculated, so lambda is equals to 0.75 for 10 years. We have already, it is given in the it is given in the example itself. So 0.75 divided by 10 years, 365 days of a year and 24 hours, so it is 8.56 into 10 raised to minus 6 faults per hours. So now mean time to fault is equals to 1 divided by 8.56 into 10 raised to minus 6. So we can find out MTTF is equals to 116,800 hours. So answer is D in this case. Now we have to find out the availability of the feeder. So it can be calculated as MTTF divided by MTTF plus MTTR. Mean time to repair is 7 hours given in the example. So 116,800 divided by 116,800 plus 7 hours. So 116,800 divided by 116,807 hours will give you 99.9940%. So answer is D, 99.99%. Now in case of question 7, the rate of failures in the given time interval is also known as the hazard rate, and in bathtub characteristic, the region where the failure rate is almost constant is called the constant life of a particular system. So answer is C, and in question 7 answer is A. Now we have to find out the answer 9 and answer 10 for a system which is available in the figure. So here the substation breaker is given, overhead feeder is given. Overhead feeder is for 4 miles and 1 mile for underground feeder or underground cable, and here there are 2 termination points after this underground feeder. So the percentage amount of 2 faults per circuit mile for OH section and 1 fault per circuit mile for UG section of the feeder for last 10 years, and annual cable termination fault rate is 0.35% per cable termination is given. Now average the repair times of the overhead section, underground section and each cable termination 5, 18 and 4 hours respectively as given. Now we have to find out the total annual fault rate. So total annual fault rate for OH is 4 miles is the length of the OH cable overhead line, 2 faults per 10 years, so it is 0.8 faults per year. For UG it is 1 by 10 into 1 mile length, so 0.1 fault per year, and for cable termination it is 0.35%, so 0.0035, and there are 2 terminations, so multiply by 2, it will give you 0.007 faults per year. So total annual fault rate of the feeder is fault rate of OH line plus fault rate of UG cable plus fault rate of terminations. So it is 0.907 faults per year. So answer is D. And average annual fault restoration time of the feeder in hours can be calculated. Sigma I is equals to 1 to n lambda I Ri divided by lambda I. So 0.8 into 5 hours plus 0.1 into 18 hours plus 2 times this value of 0.035, so 0.0007 into 4. So total answer will be 5.828 divided by 0.907, so it will give you 6.4255. So the nearby answer given over here in this example is 6.41. So answer is B. Now I am submitting the answer. So after the successful submission, this message will be pop up. So this is done.